Hello students, welcome back to the last lecture on analysis of univariate data. In the previous class, we have solved the examples on moment, skewness and kurtosis. In continuation with that, today we will solve some more examples on moment, skewness and kurtosis. Today we will solve the examples on the Bowley's coefficient of skewness. We have seen that the examples on skewness can be solved by two different formulas, that is Karl Pearson's coefficient of skewness and Bowley's coefficient of skewness. Previous class we have solved examples on Karl Pearson's coefficient of skewness. Today we will solve examples on Bowley's coefficient of skewness. Here example is calculate Bowley's coefficient of skewness for the following data. And here data is given capital in lakh rupees and number of companies. Here capital in lakh rupees are given 1 to 5, 6 to 10, 10 to 15 and so on up to 31 to 35, and number of companies are given 20, 27, 29, 30, 38, 53 and 70. Now to solve this example, first we have to convert inclusive class intervals into exclusive type. You can observe here given class intervals are of inclusive type. We have to convert these inclusive classes into exclusive classes. Now to convert inclusive classes into exclusive classes, we need to find the correction factor. We know that correction factor is lower limit of a class minus upper limit of previous class divided by 2, and that correction factor we have to subtract from all lower limit and we have to add correction factor to all upper limits. So we will get these class intervals, then frequencies and LCF, that is less than cumulative frequencies. Now we have Bowley's coefficient of skewness formula, that is Q3 plus Q1 minus 2Q2 divided by Q3 minus Q1. Means for this data we have to calculate Q1, Q2 and Q3. First we will see how to find Q1. Now first we have to find Q1 class, that is class corresponding to n divided by 4 observation. Then n is 285, then n by 4 you will get 71.25. So 71.25 will come in the class interval 10.5 to 15.5. Like that Q2 class, the class corresponding to 2n divided by 4 observation, that is the Q2 class is 20.5 to 25.5. Like that we have to find Q3 class, that is class corresponding to 3n divided by 4, that is Q3 class is equal to 25.5 to 30.5. Then we have to write the formula of Q1. Q1 is L plus n by 4 minus CF divided by F into C. By putting the values, you will get 10.5 plus 71.25 minus 47 divided by 29 into 5. Then simplify this, you will get Q1 is equal to rupees 14.681 lakh. Similarly, write the formula of Q2. Q2 is equal to L plus 2n divided by 4 minus CF divided by F into C. By putting all the values, you will get the second step, and simplify further, you will get Q2 is equal to rupees 23.469. Then we have to find Q3. Here Q3 is L plus 3n divided by 4 minus CF divided by F into C. By putting all these values, simplify, you will get Q3 is equal to rupees 30.382 lakh. Then by using Bowley's coefficient of skewness and Q1, Q2, Q3 values, put the values. Q3 is 30.382 plus Q1 is 14.681 minus 2 into Q2, 2 into 23.469 divided by Q3 is 30.382 minus Q1 is 14.681. Then simplify this, After simplification, you will get the Bowley's coefficient of skewness is minus 0.119. Since we got the minus answer, the distribution is negatively skewed. That is the conclusion. So this example you can expect in the exam for 10 marks. Then we'll see one more question. The mean and mode of weekly wages of a group of workers are rupees 45 and rupees 36 respectively. If standard deviation is rupees 18, then find the coefficient of skewness. Here mean, mode and standard deviation is given means we have to use the formula Karl Pearson's coefficient of skewness, that is x bar, that is mean, minus z, that is mode, upon sigma is standard deviation. Now by putting all the given values, you will get 45 minus 36 divided by 18. You simplify, you will get 9 by 18, that is 0.5. That is Karl Pearson's coefficient of skewness is 0.5. This example you may expect for 2 marks. Then one more question. Calculate Karl Pearson's coefficient of skewness if mean is 23, median is 25, and yes, that is Karl Pearson's coefficient of skewness is 10. Sorry, here yes is nothing but standard deviation. Now Karl Pearson's coefficient of skewness formula is 3 into mean minus median upon sigma. Then 3 into 23 minus 25 upon 10, that is 3 into minus 2 divided by 10. After simplification you will get minus 0.6. Then one more question. The mean of a distribution is 50, its standard deviation is 15, and the coefficient of skewness is minus 1. Find the median. By putting the formula Karl Pearson's coefficient of skewness, that is 3 into mean minus median upon sigma, put all the values and simplify further, you will get median is equal to 55. One more question. The distribution, in a distribution, sum of lower and upper quartile is 40, that is Q3 plus Q1 is 40, and their differences, that is Q3 minus Q1 is 16, and median, that is Q2 is 18. Then find the coefficient of skewness. Then we have to use Bowley's coefficient of skewness, that is Q3 plus Q1 minus 2m upon Q3 minus Q1. By putting all the values, if you simplify, you will get the Bowley's coefficient of skewness is 0.25. One more question is there. In a distribution, the first quartile is 142, that is Q1 is 142, and semi-interquartile range, that is Q3 minus Q1 is 18. If the distribution is symmetric, then find the second quartile. Now here given is Q1 142, then quartile deviation is given, that is Q3 minus Q1 divided by 2 is equal to 18. That is Q3 minus Q1 is equal to 18 into 2, that is 36. Then Q3 is 36 plus 142, that is Q3 is 178. Then for a symmetric distribution, Q3 minus Q2, which is equal to Q2 minus Q1, which is equal to Q3 plus Q1 divided by 2. If you simplify, you will get 160. Then one more question. The first 4 central moments of a distribution are 0, 2.5, 0.7 and 18.75. Test the skewness and quartiles of the distribution. First, we know that beta 1 and beta 2 are the measures of skewness and measures of quartiles respectively. Now beta 1 is mu3 square divided by mu2 cube. Mu3 is 0.7, its square divided by mu2 cube means 2.5 raised to 3. If you simplify, you get 0.031. As beta 1 is plus, that is plus 0.03, the distribution is slightly positively skewed. Then we will check quartiles. That is beta 2 is the measure of quartiles and it is equal to mu4 divided by mu2 square. Here mu4 is 18.75 divided by mu2 square is 2.5 square. After simplification you will get 3. And we have seen that if beta 2 is equal to 3, the distribution is mesoquartic. It is a normal distribution. Now here some examples are there. You can practice, you can solve these examples at home. First question is, calculate Bowley's coefficient of skewness from the data given below, and here class intervals and frequencies are given. Class intervals are 30 to 40, 40 to 50 and so on, 90 to 100, and these frequencies are given. We have to find Bowley's coefficient of skewness. Here class intervals are exclusive type, you need not to convert to exclusive classes, already exclusive classes are given. You simply need to find Q1, Q2, Q3 values and write the formula Bowley's coefficient of skewness. Put the Q1, Q2, Q3 values in the formula and simplify and check whether the answer is minus 0.035. One more question is there, calculate the coefficient of skewness based on quartiles. It means Bowley's coefficient of skewness. Here also class intervals and frequencies are given, but you can check here the class intervals are of inclusive type. First we have to convert inclusive classes into exclusive classes and then find as usual quartiles Q1, Q2 and Q3 and use Bowley's coefficient of skewness and calculate the skewness and check here whether the answer is minus 0.103 or not. Then the Karl Pearson's coefficient of skewness of a distribution is 0.32. Its standard deviation is 6.5 and the mean is 29.6. Find the mode. Use the formula of Karl Pearson's coefficient of skewness, that is mean minus mode upon standard deviation. Then put all the given values and simplify. You will get mode, that is 27.52. Then in a distribution, if mean is 65, mode is 80 and the coefficient of skewness is minus 0.6, find the median and coefficient of variation. Put the given values and simplify and check whether the median is 70 and the coefficient of variation, that is CV, that is sigma upon x bar into 100, that is standard deviation upon mean into 100, and check whether it is 38.46 or not. With this example, we have completed the 5th unit, that is analysis of univariate data. Ma'am is already teaching you unit number 6, that is analysis of bivariate data. In the next class, we will study the next topic, that is association of attribute, and one more topic is there, that is interpolation and extrapolation. Thank you.